Hello everyone, welcome to my channel. In this lecture, we will discuss about the separation of ethanol water mixture and its sensitivity analysis with the help of Aspen HYSYS. So we have a problem: liquid ethanol water mixture having 40 mole percent ethanol and 60 mole percent water. The molar flow rate of the feed is 100 kilomole per hour. The temperature and pressure of the feed are 20 degree and 1.1 atm. The feed is entering to the distillation column at stage number 5. There are 10 number of stages with one total condenser and one reboiler. The reboiler pressure is 103 kilopascal. The condenser pressure is 101 kilopascal. The reflux ratio of the column is 3. The distillate molar flow rate is 47 kilomole per hour. What are the composition? The question is, what are the composition or of the distillate and bottom product of the distillation column? What are the composition of the top and bottom product? What are the condenser and reboiler duty? What are the temperature and pressure of the top and bottom product? The NRTL is our property method. We will use NRTL in our property method. And the last question is do sensitivity analysis and find the relationship between the feed temperature and the mole fraction of ethanol and distillate. So what will be the relationship between feed temperature and the mole fraction of ethanol which are present in the distillate product? So first of all, we will go to the Aspen HYSYS, click on add the component, ethanol water. Ethanol water. The fluid package is NRTL. So we will select the NRTL as a fluid package. NRTL is our fluid package. This is our fluid package. Now we will go to the simulation, and here we will select drag and drop distillation column. Close model fillet window. Double click on distillation column. The feed. So we will define the feed. The feed is entering the column at stage number 5. Okay, the stage number 5. There are 10 number of stages. The total condenser and the reboiler energy is QR and the condenser energy is QC. The top product is top or distillate and the bottom product is bottom. Okay, now click on next. Once through reboiler is once through reboiler. The condenser pressure is 101 kilopascal and the reboiler pressure is 103 kilopascal. The reboiler pressure is 103 kilopascal. So okay, 3 kilopascal. Click on next. The optional, the condenser and reboiler temperature, these are optional, so we will click on next. The reflux ratio to the column is 3 and it is on molar basis, so the reflux ratio is 3. Click on done. Okay, now maximize this one. It is unconverged because we have not specific information about the column. We have not specified our column completely, so we will go to the monitor. Here it is unconverged. So first of all, we will close this one and we will define our feed. So click on feed, the feed temperature and pressure. The feed is at 20 degrees centigrade and the pressure of the feed is 1.1 atm. 1.1 atm. So the feed is at 1.1 atm. 100 kilomole per hour. Molar flow rate of the feed is 100 kilomole per hour. The feed composition is 40% ethanol and 60% water, and it's on the molar basis. Okay, click on OK. Now close this one. It is fully specified. Now double click on distillation column. Maximize this one. It is unconverged, so we will define other parameter. We will go to the monitor. The distillate rate is 47 kilomole per hour. So click on run. The distillate rate is 47 kilomole per hour. So we will stop simulation. We will change this one. Suppose I'm changing this to 50 because it's creating some convergence problem. So click on run. So we will stop simulation. Okay, we will change this one to 3.3. Click on run. So it is converged. It is converged. So we will make some changes. You can play with this Aspen HYSYS. So we will change. This is, suppose this is 50, and the reflux, we will suppose the reflux was 3.3. So now it is converged. Here you can see it is converged. Now what are the composition of the top? The question is, what are the composition of distillate and bottom product of the column? So this is the top product. Double click on this one, go to the composition. So the top product is 80% ethanol and 20% water. And here you can check the bottom composition. Bottom composition of this is 99% water and about 1% ethanol. It is 99.96% water. So very small amount of water is present in the bottom. Now if we check the bottom temperature, so the bottom temperature is 103 degrees centigrade. Pressure is this one. So this is the bottom product temperature and the bottom product pressure. And this is the heat flow of the bottom product. So close this one. Similarly, here you can see the top product temperature and pressure. The top product temperature is 78.17 degrees centigrade and the pressure is 1 kilopascal. Okay, the condenser duty, here you can see this is the condenser power 2338 kilowatt is the condenser power, and the reboiler power is 2537 kilowatt. Okay, here you can double click on this one. So this is the QC, the condenser energy. The heat flow of the condenser is this one, and the condenser is this one. Similar for reboiler. Here you can check is the reboiler heat flow in kilojoule per hour. Okay, so this is the distillation, about the distillation column. Here the condenser. Okay, now we will go to the sensitivity analysis. So here we will go to the double click on the case study. Here we will click on the case study. So here this is the case study. Click on add and click on find variable. So here I am closing this one. This is the independent variable and this is the dependent variable. So first of all we will find our independent variable. These are those variables which we select in our simulation, and dependent variable are those variables which depend on the independent variable. So click on find variable and go to the feed. So what is the relation? The relationship between the feed temperature and the mole fraction of ethanol. So feed temperature, we will change the feed temperature, and the mole fraction of ethanol in the top product will be changes as we change the feed temperature. So feed temperature is independent variable. This is the feed, and we will click on the temperature, and this is the temperature. Click on this one. So feed temperature, click on done. Okay, now define the independent variable, click on find, and this is this is the top, the distillate. Here you can, this is the distillate. We will we will find the composition of ethanol in the top product. So here the composition of ethanol in the top product. So here we the master component molar flow rate, master component mole fraction. So click on master component mole fraction, click on ethanol, click on this arrow, and mass top component mole fraction of ethanol. Okay, click on done. Now click on case study, and this is the nested case study, but we will select the sensitivity case study. So this is the sensitivity. Here you can check also the discrete and the base and shift method. Okay, but I am using the sensitivity method. The current temperature of the feed is 20, so I will change my start feed temperature is suppose 20, and the end feed temperature is suppose 70 or 60. Okay, the strip size. So the strip size is suppose 5. Strip size is suppose 5 or 4. Okay, now click on run. So here you will see this is success, success. Now click on plot. Here you can see the temperature of the feed and the composition of ethanol in the top. This is the plot. Here you can see, as we increase the feed temperature, the mole fraction of ethanol in the top will decrease. So when we increase the temperature of the feed, here you can see when we increase the temperature of the feed, this is the mole fraction of ethanol. On y-axis, this is the dependent variable, and the feed temperature is independent variable. This is the feed temperature, it is independent variable. So when we increase the temperature of the feed, the mole fraction of ethanol in the mole fraction of ethanol in the water will, the mole fraction of ethanol in the top product, or the mole fraction of ethanol in the distillate will be decreases. Here you can see it is decreases. So this was all about that how can we change, how can we study the sensitivity analysis in the Aspen HYSYS. Thank you very much for your attention. If you are new to the channel, please like and subscribe.